A coroner arrives at a murder scene at 2 a.m., immediately takes the temperature of the body, and finds it to be 92.8 degrees. She waits 1 hour, takes the temperature again, and finds it to be 90.6 degrees. She also notes that the temperature of the room is 72 degrees. When was the murder committed? So at what time was the murder committed? Well, here, the body temperature, the body is cooling. So once again, we're going to be using Newton's law of cooling. So first we need to come up with our equation that satisfies this situation. So we're going to be coming up with an equation that is of the form capital T of little t equal to a times e to the negative k times t plus c. Alright, first off, C is the surrounding temperature in the room. The room temperature is 72 degrees, so that is what C is equal to. It is 72. So next we need to find our other unknown values. So we need to find A and we need to find K. We're going to begin by finding A. To find A, what we're going to do is we're going to let T equal to 0. And at time t equals 0, we are assuming normal body temperature. We're assuming the body temperature is 98.6 degrees. So we're going to assume normal body temperature at the time that the murder was committed. So then, setting this equal to 98.6 degrees, we have A times e to the negative k times 0 plus c. Alright, by setting time t equal to 0, well, e to the 0 is 1. So we have a 98.6 equal to a times 1, which is a, plus c. Well, I should have put 72 in for c. We already know what c is. C is 72. Alright, so solving for a, subtract 72 from both sides, and we get that a is equal to 26.6. So now we can update our equation here. We have capital T of lowercase t is equal to 26.6 e to the negative k times t plus 72. So now we need to find k. Well, we have two temperature readings. We are told that when the coroner shows up, the temperature of the body is 92.8 degrees. And then 1 hour later, the temperature is dropped to 90.6. So what I'm going to do here is I'm going to let capital N equal the number of hours since the murder was committed. So we are trying to determine N, to determine when the murder was committed. And we know that at time N, which we don't know yet, the coroner found the body temperature to be 92.8 degrees. And then, an hour later, we can call that N plus 1, the body temperature was 90.6. So we can kind of think of these as two different points that have to satisfy this equation that we've come up with. And we're going to use these to create two equations to allow us to solve for N. So I'm going to take and set the equation equal to 92.8 equal to 26.6 e to the negative k n and then plus 72. So at time n, which is the number of hours since the murder was committed, the coroner gets a reading of 92.8 degrees. And then an hour later, the coroner gets 90.6 as the temperature. So that's going to be equal to 26.6 e to the negative k times an n plus 1, since it's an hour later, and then plus 72. Alright, so now we've got two equations, and we're going to use these two equations to solve for k. What we're going to do next here is we're going to actually divide one equation by the other. And the reason we're going to do that is to help solve for our variable, since our variable is in the exponent here. First, let's subtract 72 from both sides of the equation. So then what we're going to have here in this top equation, when we subtract 72 from both sides, we're going to have a 20.8 equal to 26.6 e to the negative k times n. And then on the bottom one, when we subtract 72 from both sides, we're going to have an 18.6 equal to 26.6 times e to the negative k times n plus 1. Alright, next we're going to divide this top equation here, the 20.8 equal 26.6 e to the negative k to the n. We're going to take that and then we're going to divide it by this bottom equation. Alright, so on the left hand side we have 20.8 divided by 18.6 equal to, and then on the right hand side the 26.6 on the numerator and denominator cancel. So then we're left with an e to the negative k times n on the top, and then we have an e to the negative k times an n plus 1 on the bottom. Now what we can do here, on the bottom we have a negative exponent. We can make that positive by bringing it to the numerator. So then when we do that, we still have the 20.8 divided by 18.6 on the left. So then on the right we have an e to the negative k times n. Then we're going to bring that denominator to the top, and it's going to make it a positive k times an n plus 1. Now what we can just do is distribute that k here, distribute that through in the parentheses. So then what we have here, we still have the 20.8 divided by 18.6 on the left. So we have e to the negative k times n times e to the k times n times e to the k. Alright, so now notice here the e to the negative k times n cancels out with e to the positive k times n. Alright, so now what we have here is a 20.8 divided by 18.6 is equal to e to the k. We've almost solved for k. Now we need to take the natural log of both sides. So natural log of 20.8 divided by 18.6 is equal to the natural log of e to the k. Now if we bring the k out in front, what we have here is the natural log of 20.8 divided by 18.6 is equal to k times the natural log of e. Natural log of e is just 1. So now we have k, and if we put that in our calculator and get a decimal approximation, we get that k is approximately 0.11 rounded to 2 decimal places. Alright, so now we can go back and put that into our equation that we come up with back here where we were where we set n to be the number of hours since the murder was committed. Now we have k, so we can plug 0.11 in for k, and then we'll be able to solve for n. So our equation with n is going to look like 20.8 equal to 26.6 e to the negative 0.11, now that we put our k value in for k, 0.11 in for k, times n. So now we want to solve for n. So we can divide both sides by 26.6. So we have 20.8 divided by 26.6 is equal to e to the negative 0.11 times n. So now let's take the natural log of both sides. So we have the natural log of 20.8 divided by 26.6 is equal to the natural log of e to the negative 0.11 times n. Now we can bring the exponent out in front. So what we have here is the natural log of 20.8 divided by 26.6 is equal to a negative 0.11 times n times the natural log of e, which is just 1. So now divide by both sides by a negative 0.11. So we have n is equal to the natural log of 20.8 divided by 26.6 divided by a negative 0.11. Alright, and then when we put that in our calculator and get a decimal approximation, we get that n is approximately equal to 2.2. So now remember what n is. N is the number of hours since the murder was committed. So n is 2.2 hours. Alright, so when the coroner arrived, the murder had been committed 2.2 hours prior to that. So the question asked us, what time was the murder committed? Well, 2.2 hours. Let's figure out how many minutes that is. I mean, that is 2 hours and 12 minutes. Since 0.2 is 2/10 of an hour. So 2/10 of 60 is going to be 12 minutes. So 2 hours and 12 minutes had passed when the coroner arrived. And since the coroner arrived at 2 a.m., 2 hours and 12 minutes before 2 a.m. would mean that the time that the murder was committed was 11:48 p.m. the night before.